Firstly, I'd like to call on Paul Hare as a practising architect and honorary principal fellow at the University of Melbourne School of Architecture and Building. He helped steer the environmental and architectural outcomes for the Mullum Creek development, a peri-urban eco-housing development in Donvale, Victoria, that has generally been considered best practice sustainable development. Paul's presentation today will focus on the Mullum Creek development and the initiatives trialled in ecological sensitive design. Paul and his team were able to steer those engaged at Mullum Creek through the design and construction phase of the development between 2015 and 2019 to deliver substantial environmental gains. Paul will share with us the easy wins and of course the curly challenges encountered by the developer, the local council, its departments and other authorities in achieving the environmental outcomes at Mullum Creek. So Paul, welcome forward.
Okay, yeah, as Sally flagged as well, the World Green Building Council, it's put the built environment as responsible for 39% of greenhouse gas emissions on the globe, and over half of that is attributable to housing. So if you add to that the biodiversity decline, and that's attached to the procurement of building materials and the commandeering of previously natural ecosystems to locate our built environments, it becomes pretty clear that we as architects, as engineers, builders, developers, town planners, policymakers, we're actually key accomplices to the climate and biodiversity crisis that we've got. But that said, we can also be key drivers for urgent, environmentally and socially regenerative change. And it's why there are now hundreds of thousands of Australians. They're engaged in the future of built environments, and they're in one way or another, they've mobilised in address of this emergency head on. They're changing the way they design, specify materials, innovate, and how they advocate in the community and to the powers that be. And there's no doubt this focus is where our broader social gaze is rapidly shifting. It's where business can prosper, and it's really the only way forward by which our finite and our precious planet can continue to support the civilisation in the way we know it. Now, there are three main prongs to the approach we, built environment workers, can take in this emergency. First up, we can address the operational impacts of buildings, so their energy demands in heating, cooling, lighting and the like, and also their water consumption. And this has been the predominant focus to date. Secondly, we should address the impacts embodied in construction of materials. And finally, we need to address the amount or the scale of building that we think we need, because that has the most significant impact on the first and the second prongs, but it's really hardly ever spoken about. So I'll address each of these three prongs using the Mullum Creek to explain some key points. So I worked on the Mullum Creek housing project from 2002 to 2019. It's a 56-lot estate and it's still under construction in one of the last pockets of residential land that's remaining undeveloped alongside the Mullum Creek, just 20 kilometres east of Melbourne CBD. Its beautiful natural setting was the childhood home of the project's developers, so Sue, Steve and Danny Matthews. Now these days the property, it's virtually surrounded by subdivision of possibly the least environmentally sensitive kind. And that's because the scale of many homes on minimum 1 acre lots in that neighbourhood is jaw-dropping. So the status quo for council and for local residents, it was really challenged when the Matthews family first applied to develop the property as an exemplar for sustainable living, and that was back in 2006. Central to their environmental vision was to donate almost half of the property of the 56 acres, so that with the higher natural landscape value along the creek and in the valley that feeds it, and to donate that to the public as a nature reserve that now forms part of a larger linear park, and to enrich this reserve with sensitive landscape works that extend into the residential streets. The developers, they had an as of right to subdivide the property into 56 1-acre lots, but they hoped that council would be favourable to a proposal to subdivide the remaining land with lesser natural landscape value into 56 much smaller lots. And most of that land was open paddock where an apple and pear orchard once grew. Now, it took the Matthews family a further 6 years, so until 2012, to get this fundamental master planning strategy across the line with the city of Manningham. Here's just a few snaps I took recently that show how this planning strategy has already expressed itself in the landscape, even while there's still some homes being built. One thing we desperately didn't want at Mullum Creek was solid fencing between lots, because that visually carves up the landscape and it blocks neighbourly engagement. We copped our share of resistance for it initially from lot owners who were chasing old school privacy, but we pressed ahead by requiring and facilitating the erection of open rural post and wire fencing, because that allowed a range of fence heights. We could add mesh to contain pets, as well as creative constructed and planted screens for portions of fence runs where the residents really wanted that extra bit of privacy. 4 years on, I'm told that the residents pretty well all really love this open fencing. Now, Mullum Creek, it applied those obvious sustainability initiatives to achieve really good environmental outcomes, like requiring for each house a minimum 7.5 star energy rating, a minimum 4 kilowatt rooftop solar power installation, a minimum 20 kilolitre rainwater storage so they could be the water could be reused in toilets and laundries and gardens, and energy and water conserving plumbing, mechanical and electrical systems. From early project framing and preparation of the Mullum Creek design guidelines, and they're tied to by a Section 17 agreement to the purchase of lots at Mullum Creek, we, as the design review committee for the developer, we were able to support many lot owners, architects, engineers, landscape designers, as well as building and landscape contractors, through a formal step-by-step process, both in design review and in construction overview. And that engaged them then in worthwhile environmental practices, and many of which they'd really not encountered before. I won't have time to explain here how the design guidelines and the Section 173 agreement and the contracts of land sale and the working relationship between the developer and the local council were structured for Mullum Creek. But my awesome colleague Rafi Cruz and I would be really happy to discuss that with anyone interested over dinner or any other time. Just give us an oi. While still on the subject of landscape, you can see how the Mullum Creek design guidelines have steered the selection of rock and gravel and wood and plant material for road reserves and front yards. And together with the open fencing, these natural elements are successfully connecting homes with the nearby bushland. They also soften the social interface between public and private open space. Okay, so action prong number 1 in address of our climate and biodiversity emergency. So certainly until recently, the focus of building industry and codes has been on improving that operational energy efficiency of homes, as that relates to their thermal performance, as well as the efficiency of fixed mechanical and electrical services. So the thermal performance is based on benchmarks that are currently set by the National Construction Code at 6 stars, and in May next year that bar is going to be raised to 7 stars. But in 2016, Swinburne Uni and consultants Pitt and Sherry, they confirmed what some of us had long feared, and that's that the value of Australia's home energy rating system, NATERS, is seriously eroded by lax and optimistic software data entry when assessors are often modelling the homes for their performance as designed, and also by material substitutions and poor construction detailing on site of new homes. So these practices, they commonly reduce the thermal performance of homes as they're built by 1 to 1.5 stars below their certified rating, which is that what this research showed. And you can see here in the table how significantly that increases energy use. So a high energy rating predicted for a home in design is one thing, while independently verified energy performance of a home as it's built is another, it seems. So here in Ballarat, this problem with implementing the energy rating system, it could possibly be addressed in a similar way to how it has been at Mullum Creek, by implementing a memorandum of common provisions or a covenant tied to the sale of the lots. The City of Ballarat could commission one rigorous energy assessor to guide developers, designers and builders without fear or favour, and to do it at arm's length to secure, via a step-by-step review of design and construction phases, an independently verified, as-built, minimum, say, 7 to 8 star energy rating for all homes on an estate. It's possible. This service would conclude with a certificate of thermal performance based on predefined checks at construction milestones. So they can be things like blower testing for air tightness, as well as visual checks and thermal imaging for insulation continuity and for door and window installations. So the service that could be billed to the council, and the council could get that reimbursed via the levy it normally applies to building permit fees. And this then properly ensures that the thermal performance designed into a home is carried through to the final constructed outcome. And there are obviously substantial benefits in reduced energy bills and greenhouse gas emissions to be had through that. Now, achieving an independently verified 7.5 star thermal performance is actually not that easy for a detached home. At Mullum Creek, we found that homes with anything other than a compact architectural form and modest, well-oriented glazing, it had really struggled to achieve 7.5 stars in Melbourne's cool, temperate climate, unless they've got all the following other design features in place, and that is high levels of insulation in the external walls and under roofs, double or triple glazed windows with high thermal resistance and high solar heat gain coefficient, and interestingly also substantial and continuous insulation of the ground floors, particularly slabs. And this will be, I'm pretty sure, even more the case here in Ballarat with your cooler winters and cold nights. Now, constructing an on-ground concrete floor with continuous under-slab insulation, so that's to provide good, uninterrupted thermal resistance with no thermal bridging from the ground up, and internally accessible thermal mass, it's technically challenging, it's potentially quite expensive, and for the most, it's something unfamiliar to Australia's home building industry. So for Mullum Creek, we advanced some better solutions for this through our ground slab insulation guide that you can find on the website. So at the top left, the schematic there shows a flat plate slab, which is over XPS insulation board, continuously across, and that's over a strip footing grid. And to the right of that is a more technically resolved section of the same. And here in Ballarat, I went for a bit of a drive today, had a bit of a look around in the new subdivisions. You've got some flatter sites, obviously, than we had there, and maybe some also with more stable soils. But either in their own right or with board piers, you might be able to quite affordably construct a waffle slab over a continuous base of XPS board, so a layer of XPS and then the waffle pod slab on top of that. And the bottom left schematic flags that. That'd give your slabs an awesome thermal performance for this cooler climate. So as building codes are now raising the required performance of new homes in cool climates like Ballarat from 6 to 7 stars, I reckon they need to also include some default design solutions for continuously insulated ground slabs. So to support this raising of the bar, that's going to be mandated in May next year. In these southern parts of Australia, homes with high thermal performance and or rooftop solar power systems, they're crucially reliant on good access to low winter sunlight for obvious reasons. Not only within a lot, but also between residential lots that needs to be thought about really carefully. To that end, at Mullum Creek, we modelled and we prescribed 3D building and vegetation envelopes, and they were necessarily specific to each lot because of the hilly estate and the land moved around all over the shop. And inside of those envelopes, all construction and newly planted trees in their expected mature form, they'd need to be contained inside those envelopes. Unlike the standards that apply via building regulations and planning mechanisms to other housing developments in cooler climate zones of Australia, these Mullum Creek envelopes, they preserve full interlot solar access for each home, even in the depths of winter. So we simply placed dwelling forms as they were submitted to us for design review into their prescribed envelopes on the terrain of our 3D CAD master file. And then it was quite easy to see where dwelling forms were going to encroach these envelopes and risk overshadowing neighbouring homes. Now, the home sites at Mullum Creek, they were upwards of 1,000 square metres in size. And preserving solar access between lots obviously gets more challenging as the lot size reduces. But even in small lot subdivisions, there's a lot you can do beyond satisfying the overshadowing standards set by the Victorian building regulations for livable housing to better provide solar protections between homes and between home sites. So prescribed 3D envelopes that elicit house designs that provide generous open space with good exposure to low northern sun, even when that sun aspect is to a side boundary. And I'm not seeing much of that sun-conscious planning in street layouts or in the built forms of Ballarat's new residential subdivisions. Okay, so what about construction materials, this action prong 2? There aren't really such clear figures for Australia, but those of us who are engaged with this stuff are slowly coming to the realisation that environmental impacts that are embedded in the average Australian home from cradle to grave are actually greater by way of materials that are used for constructing and repairing it than by way of energy and water that's supplied to service it through its functional life. So per square metre of floor area, the operational energy and water efficiency of new housing in Australia, it is slowly improving. But what that means is that the materials used to construct homes remain actually as the primary driver to their overall life cycle environmental impact. Building services and appliances that are attached to the operation of homes, they can be upgraded to embrace new technologies and to provide improved energy and water efficiencies through what needs to be a long service life for a home. But our specification of concrete and steel and bricks and wood, that's got much more potentially serious environmental impact and more carbon emissions that are almost immediately and irreversible as you build the home. And it's, as Sally mentioned as well, about it's when you build the home, that's when it's pretty hard to make change. So that then is really an awful inheritance for our younger generations by way of natural resource depletion, biodiversity loss, and of course, crippling climate change. So when we're planning and constructing a new residential subdivision in Melbourne or Ballarat, its overall environmental impact across the next 10 years being this crucial emergency period in our address of climate change, as the science tells us, that impact will be tied primarily to the materials that are used to construct it. Cement and concrete products, fired clay bricks and tiles, steel, timber, they're currently the most impacting elements, and they're locked into our homes as they rise from the ground. Now for Mullum Creek, we prepared a series of materials info sheets that attach to the estate's design guidelines, and they direct lot owners, designers, builders to products that come with relatively low environmental impact. And you can find these guides together with a bunch of related YouTube presentations on the website that's listed here. They're all free and deliberately we want to share them as widely as we can. Let's quickly just look at concrete and cement and timber as example. At Mullum Creek, we were able to steer the use of those materials by requirement through the Section 173 agreement. The World Green Building Council, again, it tells us that the manufacture just of Portland cement, being what binds the stone and the sand in concrete, just the Portland cement accounts for a whopping 8% of the planet's total greenhouse gas emissions. So roughly the same as the entire transport sector, just in manufacture of cement. Now there are alternative, equally effective and readily available concrete binders, such as fly ash, which is a waste from coal-fired power generation, and slag, which is a byproduct from steel smelting. And there are many others as well, but not commercially available at the moment, still in research, but looking good. These alternative binders are collectively referred to as supplementary cementitious materials, or SCMs, and the environmental impacts attached to their manufacture are way less than for Portland cement. The Mullum Creek design guidelines require that SCMs make up a minimum of 30% of the cement used in wet mix concrete. We wrote that into the guidelines 8-9 years ago. If we were doing it now, we'd up it to probably 45 to 50%. Some of the architects and engineers at Mullum Creek, they chose to increase that up to around 60% in the mix of, and they did that particularly where the surface finish wasn't critical. So for in-ground piers, strip footings, retaining walls, those sorts of things. As construction commenced on the estate, we found that more and more local batching plants were happy to supply concrete with SCMs with no increase to supply cost. There was initial resistance to SCMs by builders and concreters, but that subsided as the concreters found that ground slabs containing SCMs were stronger and with less shrinkage cracking. And the bricklayers also, they realised that bagged cement containing 50% SCM was equivalent to general purpose Portland cement in its availability and in its performance and in its price. So towards substantially reducing the carbon footprint that's embedded in new homes with a no-cost, no-brainer, I strongly always encourage designers, engineers and developers and local government to insist on concrete with SCMs replacing Portland cement in the highest proportion that's appropriate for any given application. Preparing for this talk, I phoned up Ballarat's 3 main concrete suppliers. They all offer wet mix with elevated SCM, but some are pushing environmental innovation more energetically than others. Some are willing to also include crushed recycled concrete in with the aggregate mix for those lower strength applications, again like the piers, the sub-base, blinding concrete, that sort of thing. And some use hot water rather than chemicals in their mixes to speed up concrete setting on your cold winter mornings that you have here. I was advised that high SCM mixes are finding their way to most Vic Roads constructions sites around Ballarat, as well as to many local government projects, and that's terrific. But I understand that contractors laying concrete for house slabs and pavements, so those that are responsible for a larger share of what's poured in Ballarat, they're less likely to order these environmental mixes. So could the City of Ballarat simply require, as a condition of planning approval for a new residential subdivision, or as a covenant on the sale of lots, that all wet mix concrete and all bagged cement that arrives on site contain SCMs to minimum specifications for an application? To give that teeth, this requirement would need to be monitored via good keeping of delivery dockets, which detail mix specifications, and by occasionally also testing some mortar spoils, some concrete and mortar spoils. And this could be a further role, maybe, for a sustainability consultant that council engages, maybe having them on staff for confirming as-built thermal performance and the specifications of cement. Bagged cement with higher SCM content is also readily available in Ballarat. I checked this morning, but knowledge around its better environmental performance needs sharing more widely among bricklayers in particular. Once they open the bag, they won't be able to tell the difference, I'm told. As an architect, I love working with wood, but it troubles me that much of the structural and the architectural timbers we use in Australia, they're sourced in ways that contribute to the demise of the world's natural forests. And in this climate and biodiversity crisis, desecrating the lungs of our earth for timber and for pulp is as suicidal as it's disrespectful. By example, the tropical rainforests of Malaysia, Indonesia and PNG, they're definitely where many of our great Aussie decks come from. Certainly all those that are built in Merbau. So you'll read it everywhere. Wood is good, it's the ultimate renewable. The truth of the matter is that timber can be the very best, or can also be the very worst material you'll build with, depending on where and how it's sourced. The current rate of deforestation of northern hemisphere boreal forests, it's going to have catastrophic impact on our global climate if it continues at anything like its current pace for producing timber, paper, and believe it or not, even wood pellets for feeding power stations in Western Europe and the UK. Over the past 10 years or so, but it seems more so in Melbourne than in Ballarat, house framing timber has moved away from being mostly radiata pine, that's fast grown in Victorian plantations just west of here, and milled within an hour's drive of here, the largest softwood sawmill in Australia, AKD. Substantially now, this framing softwood is also Baltic pine and spruce, and it's sourced from those very slow-growing, cold climate boreal forests on the other side of the planet. And many of them are intact, mixed species, broadleaf and conifer forests of Russia and Eastern Europe, and we're still getting Russian timber into stores here. Our local pine and this imported spruce, they're stacked together on the racks in many timber yards, including here in Ballarat. No labelling to differentiate them and the same price. But if you check the end grain, it'll tell you the story. You can see on the top left, just local grown, fast grown radiata pine. There's maybe 4 to 8 years of growth in a piece, 90 by 35 in section. And on the right-hand side, you'll see 100 years of growth in exactly the same cross-section of wood. Very, very slow grown in cold climate of Baltic and pine and spruce. When it comes to engineered softwood beams and all wall bracing in homes, and not all, sorry, in wall bracing in homes, also here in Ballarat, they're now mostly from these boreal forests, the timbers for those. So timber harvested insensitively from natural forests, which is mostly at huge industrial scale and for global markets, that can result in serious and irreversible impacts on flora and fauna, on soil health and waterways, and it can reduce and even reverse a forest system's sequestration of atmospheric carbon, and of course it can erode the well-being of rural and Indigenous communities around the world. But timber can also be recycled, or it can be sourced locally from fast-grown native and exotic plantation trees, and they can contribute to the social and economic well-being of rural communities. And above all, it's going to preserve our natural forests for the many other ecological services that they provide us. So Mullum Creek, it required that timbers used on the estate be selected according to what were quite strict environmental and social criteria. And that still left many good product choices to suit all applications and all budgets. We've compiled and we regularly update comprehensive lists of readily available timber products to satisfy these criteria. So check them out on the Mullum Creek website if it's of interest. So we were really pleased with how designers and particularly builders at Mullum Creek have embraced the sustainable timber products that we've required them to choose from. And we know that they're now carrying this new product awareness to their other jobs. In 2016, with a leg up from the Mullum Creek project, Ceres Community Environment Park in East Brunswick, Melbourne. I don't know if any of you people know that. It's been around for 40 years. It's a wonderful place. It was able to establish a not-for-profit social enterprise called Ceres Fair Wood. And Fair Wood aggregates and it retails timber inside really short, local, transparent supply chains. So from Victorian and Tasmanian tree farmers and sawmill operators who they know personally. And they're really small producers who are geographically dispersed, and they struggle to find, to sell and to deliver to a market that fully appreciates the farm-grown trees and timber that they have on offer. They can't trade with Bunnings and the big players. They're not interested. Fairwood buys only from growers and millers who source wood to the highest standards of environmental and social responsibility, and that's informed by the Mullum Creek project. It shares their stories with its customers, building and landscape contractors and furniture makers, DIYers. And Fairwood Business obviously builds direct friendships and understanding between city and country folk, and it encourages farming families to revegetate their bare paddocks with trees for conservation and also for profit. And of course, all the profits from Ceres Fairwood, they go back into Ceres Community Environment Park. As another low-hanging environmental initiative, so decision makers in building and development across Ballarat could simply require, again via covenant, that all framing timber for new homes, that it be sourced from fast-grown plantations that come from Australia and New Zealand. And that alone would hugely help preserve the biological health and the atmospheric carbon that's stored in natural forests across the planet. And it'll also send a really strong message to the broader timber industry that we're entertaining only wood that's sourced with true responsibility. And for higher value architectural timbers, supporting those local not-for-profit environmental enterprises like Ceres Fairwood can only be another good news story for a builder or a developer for the City of Ballarat. Finally, action prong 3 in address of our climate and biodiversity emergency. Here's an infographic which shows how in just 26 years between 1984 and 2010, house size across Australia nearly doubled in those years, 26 years, from 50 to 87 square metres per occupant. And the other week, your council's social planning officer, Hayley Kane, she compiled some really terrific local stats for me from the 2016 census. New residential subdivisions in Ballarat's Western Growth Corridor are showing similar patterns to those graphed here. So big houses, small households or number of occupants, and lots of empty bedrooms. For me, the only really disappointing thing about the Mullum Creek project was our failure to adequately cap the scale of homes that were built there. We did contain house size with limits to site coverage and with 3D prescribed building envelopes that I mentioned earlier, but that wasn't enough, and there are some monster homes on the estate. How do we compare on this with other countries? As Sally also raised, the overall environmental impact of Australia's housing stock is pretty much as high as it gets, simply because the floor space attributed to each occupant is higher than almost anywhere else in the world. So, as designers and developers and policymakers, the very best thing that we can do in this emergency is to demonstrate with an urgent passion how small can be beautiful in our dwelling experience. Because it can avoid us overstretching our finances and allow for other joys and challenges that are ahead. Or if we've got cash to splash, we're better to invest in quality and craftsmanship that supports fine workers, rather than in quality that draws so heavily, that draws so heavily on our planet's finite natural resources. And where possible, if we can appreciate and delicately improve what we already have, rather than to knock it down and to start again. This small home at Mullum Creek is built in rammed earth and local plantation pine, and it was awarded the Australian Building Design of the Year by Design Matters National in 2020. So all the quite rigorous ESD requirements guiding the design and construction of homes at Mullum Creek, they've still left plenty of scope for fine architectural expression. I recall several builders completing homes at Mullum Creek saying how they really enjoyed and they learnt heaps from the new challenges that we imposed on them, and how they were keen to shift their broader business practice in this direction that we'd taken them. And that's because, as they now see it, it's where their industry is going and they want to gain an early market edge. Also, as volume builders and developers, I reckon you'll thrive in the times ahead if you can lead the way in building more climate-friendly and resource-efficient homes and housing estates for a market that's increasingly sensitive to the economic and the social and the environmental ills of hyperconsumption. And aim high with this because, as we came to learn at Mullum Creek, yesterday's outrageously bold propositions become tomorrow's no-brainer. So only 10 years ago, we struggled and we failed to get Mullum Creek plumbed up without town gas, and instead to have it wired up, ready for a renewable all-electric energy future. So ready for things like microgrids and electric vehicle charging. Today it'd be negligent not to service a new housing estate in preparation for this shift. And what's in all of this for the City of Ballarat? As many local government areas in Victoria are now declaring a climate emergency and they're locking in their climate action plans, it's terrific to see those that are aiming high. They're tackling more than just operational carbon emissions from their council vehicle fleets, their street lights, their offices, their depots, their civic centres. In 1979, just half an hour's drive north of here at Maryborough, it's where I found the gate to my path as an architect. I was just fresh out of uni. It was there 43 years ago that the local shire was actively supporting home energy efficiency initiatives then. They were supporting freshwater aquaculture ventures, publication of the first permaculture magazine, revival of an earth building culture, and a swag of small manufacturing startups in low energy technology. My sense is that Maryborough will have certainly had a big part in seeding the vibrant eco-culture that we now see in and around Castlemaine and Daylesford. It's also in big part where the vision for Ceres emerged. So here locally is where we can aim high and we can make a difference, where we can model better ways forward via well-supported community action. That old adage, think globally and act locally, it rings truer for me every passing year. So thank you everyone, and especially Sally from Breeze for inviting me to share this story about Mullum Creek with you. Thank you.